Okay, so who are we and what do we do and what is this presentation about? Okay, so we are actually Brighter Education Group or Brighter Prep as we are known in this market. Okay, so what are we? We are a study abroad consultancy. Okay, so we actually cater to a lot of students who get inside the sort of Ivy League sort of institutions that are in the United States, or even some of the high Russell Group institutions that are there in the United Kingdom. Okay, so as a study abroad consultation, we offer a few things, right? So what am I? Actually, I'm a consultant, and one of our biggest services that we offer is actually helping students build their profile to various what do you say disciplines that they would like to get into. Okay, and what we do as part of this sort of portfolio building or profile building is also we work with a few experts within this industry. For example, Rise actually is our partner currently, and they are actually go through their process as to how they can actually help us with this particular endeavor. Okay, so our presenters are actually Miss Asia. She will actually go through her company, how this particular service is going to go throughout the entire journey of a student, right? And how we also can work together. All right. So thank you. So I will pass it on to Miss Asia. Miss Asia, are you there?
Yeah, hi everyone. It's lovely to be here. I'll just introduce myself quickly and then we'll talk more in a little bit. But my name is Asia. I'm a PhD candidate at the University of Oxford. I'm a biologist and I'll go in a bit more to what I do shortly. But I'm also really passionate about kind of outreach and engagement, particularly in the sciences, but just in general. So yeah.
Hi, I'm so sorry to interrupt. I just wanted to make sure that you've made Shreyans a panelist and not a participant because I believe he's joined in as a participant and we won't be able to present in
Okay,
that case.
let me just try getting him in as well. Okay,
Yeah.
Asia, you can continue as it is. Yeah.
Sure. Okay, excellent. So, as I said, I'm a DPhil, which is another word for PhD at the University of Oxford. And my overall specialism is evolutionary developmental genetics and bioinformatics, which is just a fancy word for effectively saying that I use computer code to understand how genes work, how they evolve, what they do, and why they're important to life on Earth today. So I'm at Keble College, specifically at Oxford. And as I said, I'm very passionate about student outreach. I myself am the first in my family to go to university. And therefore, for me, I've always made it something that's really important is to engage with students into higher education, into different research and things like that. And therefore, I've worked with loads of different organizations to kind of convey scientific ideas and various things like that, like I'll be doing today. And as you can see on the slide, I run a blog on Instagram where I talk about my life at Oxford. I talk about science in general. I talk about higher education and things like that. So if you're interested in that, please do follow. But on top of all my work, I recently won the Public Engagement Award at the University of Oxford for everything that I've done. And I've also published my own research in a journal called BMC Genomics, and I have two further publications as well on the way. But I also myself, as an undergraduate and when I was in high school, engaged with lots of different research projects. So hopefully I can give some of the benefit of that knowledge to you today. Could I have done it? Fantastic. So before we go into that, what is research? So research effectively creates impact and new knowledge across multiple different fields, and it involves looking at something that hasn't been studied before, using maybe new methods or changing the way methods currently exist. And the benefit it is, it opens doors to journals and conferences. As I just said, I myself have published research in journals which undergo things like peer review, which means other scientists or researchers critically evaluate your own work. And they give critiques and things like that before published to make sure that we have good data effectively. But the benefit of that to you as well is it enhances your critical thinking skills, which we'll go through in a bit. But it also looks fantastic on university applications. So today we're going to talk a lot about research mistakes that people commonly make. And first of all, many strong ideas in research lose their impact due to weak execution. And like it says here, that small mistakes can make your research seem less credible. And that can be mistakes in your kind of methodology itself, or even down to spelling mistakes. So it's really important that when you do research, that you kind of go through your work, you ask others to help you kind of proofread it and things like that. You want to make it look as professional as you possibly can. And knowing what to avoid is just as important as knowing what is really important to do. So we're going to go through a series of errors that students commonly make. And hopefully this can be used by you to benefit your own research going forward, and avoid those mistakes and have a really good research publication. So what makes good research? So there are several things that make good research, but here are 4 pointers. So first of all, good research is focused. And this means that you have an answerable research question rather than something really broad. Typically, if I've always been taught, if you write a research paper or journal or anything like that, that your kind of the title that you put on your research should be answering a very specific question. And now you can use lots of sub questions to answer that as well, but it has one overarching question which can be answered. So secondly, it's structured and it follows a logical and consistent flow. And typically this is goes in the format of an abstract, an introduction, your methods, your results, and your discussion. And this can vary slightly. If you look at different journal articles, there could be slightly variations on titles for those things. But overall, and particularly at kind of this level, those are the subheadings and structures that you want to be following. But that being said, when you actually write these, I quite often recommend that people write them up in a different order to the way they are structured on a piece of paper. So for example, you might look at writing your methods first and your results and actually your introduction last, because I find it helps you give a much more concise introduction and abstract once you have a full understanding of what your results are. So next, good research is evidence-based. And this effectively means every claim or finding has data and the correct analysis of the data to back it up. You're not just kind of giving thoughts or feelings, you have to do it with facts and often tie this in with existing literature or research as well. And finally, it's original. So as I said, it has to be a new question effectively that has not previously been answered. But really good research places your findings in the context of research that's already been done and talks about the significance and why it either agrees or disagrees with what's out there already. So, and we're now going to go through a couple of mistakes. So the first mistake is what we call a weak problem statement. And as I said, one of the kind of good signs of research is having a focused topic or title. So we've got an example here of kind of a topic that's too broad, which is just climate change impacts, versus something you might consider a stronger problem statement, which is having a specific aspect of climate change. So in this case, it's crop yields in India. And the purpose of this is when you're going to ask this question, you're going to walk the reader through how exactly you're going to answer it. So what methods you're going to use, how you're going to analyze it, and how that answers each of the sub-questions you're going to use to answer this overarching question. And tied in with this is what you need a rationale. So weak research often lacks a rationale. Effectively, why does this matter, or why is this research important, or why does it fill a gap that we currently have in that knowledge area? Another kind of mistake that comes under this title is poor alignment with research methods. And what this effectively means is you might collect data and talk about it, but it doesn't actually answer the question that you've said you're going to answer. So when you're looking at research or the question you want to answer, you really need to think critically about what data am I going to use to answer this, and what kind of data transformations or analytics am I going to use to help me draw conclusions from it. So make sure everything aligns and answers the questions you need all the way through. So just to add the kind of solution to these, or what a good example is defining the scope and the variables clearly. So as I've said a few times, I find it very helpful to have an overarching question and then have maybe 3 aims and corresponding objectives for each of these aims that you're going to use to answer that question. Secondly, you want to explain the relevance and the objective. You want to talk about, for example, if you were using this impact of climate change, why is climate change important? Why does crop yield matter in India? And what are you going to go and do to find this answer? And thirdly, so this ties in quite a lot with what I've just said, but turn your topic into a specific and testable question. Now, this can be a question that you can test with maybe statistics, or you can collect data and analyze it in some other way to find a conclusion of kind of yes or no, something happens. So another common mistake is poor research design. And this is something that's incredibly important for your study, whatever level, undergraduate, postgraduate, or even before that. Having a solid research design is incredibly important. And it's always good to kind of run this by others who might be in the field or have some knowledge of it to make sure that you have a really robust research design. So firstly, don't choose a method just because it sounds complex or it sounds cool. Really ask yourself, is this a method that's going to help me answer my question? It's far more important to use a simple statistical test that yields good results than something really complex that doesn't answer your question. So next is a lack of consistency between research question and data collected, which I mentioned on the last slide, but it's something very important. And it's making sure the data you collect is going to answer one of your aims to help you answer that overall question. So if you're going to talk about crop yields, don't kind of collect data on something completely different to do with climate change. Make sure it relates in some way to crop yield. It might be crop growth, it might be weather and how that influences crops, for example, but make sure it really aligns with what you're asking. And thirdly, another kind of mistake under this poor research design is not defining key terms or control variables. And so key terms is quite straightforward. It might be scientific terms or jargon used in that particular field, but might not be well known to others outside of the field. So it can be really useful to have some kind of glossary or definition section in your research so that everyone can follow. And secondly, control variables, excuse me. So control variables is effectively something that doesn't change throughout the experiment, and it's something that can be used to compare to a variable that you do change. So the control variable essentially proves that whatever you change is responsible for that scientific change or something you measure. So the solution to these is picking methodology that suits your question. So one really good way to do this is to look at maybe research or journal articles that have been published under your desired topic and see what methods they might be using. You might want to evaluate how to make the method better, for example, but look at what's been used in the field or try and talk to someone that has experience of it. Secondly, justify your design choices. So this comes back to your critical thinking of, what makes sense to use in your particular research. And thirdly, identify limitations openly. And this kind of identification of limitations usually goes in your discussion section. And it doesn't have to be a kind of weakness to your research at all. It's really important as a scientist to acknowledge what limitations your study might have. And you can put a positive spin on it by saying what you might like to study if you had more resources, more time, or something in a further study. But it is really important. No scientific research journal claims to have the answers to everything. So it's really important to acknowledge what your study hasn't achieved, but also what it has achieved. Oh, next slide. Lovely, thank you. So the next one is weak data collection. So I think if possible, it's really important to make sure you collect your own data. So one weakness can be relying entirely on secondary data without verification. And this is effectively where you use data maybe from some other research. You might not understand the research methods they used or where the data exactly came from. And because of that, you can't analyze the weaknesses of it, or you might not have a full rounded understanding of data. The next one is small or biased samples. And in different fields of research, you definitely have a specific sample size which is accepted. For example, if you're going to look at crops, you can't look at one singular crop in a field and draw loads of conclusions from it. You're going to need multiple crops. You might look at multiple areas. And this is making sure that what you're seeing isn't an anomalous data point, which is a data that kind of sits well out of what data you'd normally have. And thirdly, another point of weak data collection is unclear data sources. So you're not really sure how or where this data has been collected, or collection procedures, so the method they used to collect this. And so to support this, you can use multiple data sources for validation. So you might want to look at something that's been published, that's been peer reviewed, and that's had other people kind of say, yes, this is good and reliable data. And usually in journals, they give very detailed methodologies on how their data was collected. You could also collect your own data if appropriate, so you know exactly how it was done and you make notes of your methods. You also want to make sure that your sample is representative. So like I was saying above, if sample sizes are too small or biased, that is not a true representation or an unbiased sample. So this is something really important to think about. If you're going to go out and collect data, where are you going to get it from? Are you going to look at different times of the year? If you're looking at crops, various things like that. And finally, being transparent about how and where data was gathered. So this, I think it's very important if you do this to make sure you kind of write down as you go along exactly how your data was collected, what methods you used, where, conditions, and things like that. And making sure it's really transparent about where your data comes from. And this ties into making sure your data is reproducible by other scientists, for example, because they can follow those exact same methods and see if they get the same result. Excellent, thank you. So mistake number 4 is poor data analysis. So analysis of data comes after you've collected it. So once you've got your data collected, that's simply just your raw data. Whereas analysis can be used in different statistical tests or various things like that to pull significance or other factors out of it to show a specific result. So first mistake made is summarizing data instead of analyzing it. So the difference is summarizing data is basically just giving a generic overview of what you found. Whereas analyzing it, like I've just said, you might use a statistical test such as an ANOVA or a t-test, and this will give a significance value, and this will tell you if the difference you see in whatever data points is statistically significant, rather than just looking at it by eye and drawing a conclusion. The next point is misinterpreting correlation as causation. So you may have heard this before, but correlation does not always equal causation. You can sometimes get graphs that makes it look like one particular factor has an influence on another, but it can be something entirely different affecting that. So this is where your control variable comes in. And this is what kind of helps you make sure that there is a correlation between your data points for whatever topic you're going to specifically look at. And thirdly, in data analysis, it's really important not to ignore outliers or contradictory results. In science, I'm sure all of us have had results sometimes that are very much not expected, but that doesn't mean they're not real. I'd say if you do get contradictory results, you might want to just double check your methodology and your data to make sure it is correct. But if that is the case, then you can still talk about this in your results. Just because it's not what you predicted, that's fine. But also when you have outliers, it's really important to acknowledge these when you analyze your results. And you can often do different data transformations to do what you call normalized data. So this stops the outliers kind of swaying or biasing the data in one particular result. So the solution to these, I definitely recommend using statistical tools. I personally prefer RStudio, but there are lots of different ones like Excel or SPSS. And there are loads of tutorials online where you can learn to use this software, but this does statistics for you. And then you can look at significance values and you can create graphs or different visuals to help kind of convey this to your audience. Make sure you explain what the data actually means and not what it just shows. This is something really common that people do. But again, this is also tying it back into existing literature. You might see a pattern in the data or a significance value, but what does that mean? What impact does that have on the science or the results? And finally, make sure you link your findings directly to your hypothesis. So particularly when you do stats, you usually have what's called a null hypothesis. And when you look at significance values, this either proves or disproves your hypothesis. And this is why, again, it's important going back to that structure of that overarching question and then having mini aims or mini questions to answer it, and make sure that your structure completely follows through of when you're asking, is your data really answering the questions that you want to ask? So that's incredibly important. Don't just kind of do statistics on things you think look interesting but aren't going to answer your question. Okay, so mistake number 5 is disorganized writing. So I talked about this when we talked about structure, but poor flow between sections. As I said, there's typically a recognized structure for how any journal article or research paper flows. But make sure, one thing I was taught and a really valuable piece of advice, that every time you start a new section, almost give a mini overview of what you've done so far. So particularly in research papers, it's really common for people to only read certain sections or to read different sections on different days, something like that. And so when you get to your results section, even though you might have a great methodology section of what you've done, give a short 1 to 2 sentence summary at the top of exactly what you did to get those results again, and just keep the reader engaged, and that helps flow between your different sections as well. So this ties into the kind of unclear or missing sections. So make sure you do have all those sections I talked about. So as I said, starting with an abstract, which is almost a mini summary of what your research is going to do. Then your introduction usually talks a lot about the literature that's already known in the field. It's where you introduce your research question and you explain why there are gaps in that field that you're going to fill. Then you have your methodology, where you talk about how you collected your data, what statistics you might have used, etc. Then you go to your results. This is usually where your graphs or any visuals are of you analysing your results, not just summarising them. And then your discussion puts your research in the context of the wider field. So I think I've kind of covered all the solutions in that, but make sure you kind of know this outline in your head before writing. I find it really useful, particularly for results section, to make a mini bullet point kind of section of the story you're going to use in your results and how each graph or whatever visual you put in is going to flow from one to the other to keep that narrative moving. Should go without saying, but make sure you use clear section headings. Don't write in bullet points, just use them as your guide when you're writing. And make sure you write with clarity instead of complexity. It's really common, particularly when you start reading journal articles, they can be incredibly complex. They can use a lot of language you might not understand, but try and write as directly as you can. When I teach people to do scientific writing, I always tell them when they look at their sentence to look at all the words in it and ask themselves, is each word in this sentence actually contributing to the sentence overall or what you're trying to say? And if it isn't, you can delete those words. Don't try and make your writing as long as you can for the sake of it. Clear and concise writing wins every time, and it makes for a much better research paper. So number 6. So I think I've talked about this kind of weaving it through all the other mistakes, to be honest, but kind of the so what? Why is your research important? And again, this refers back to making sure you put your results in the kind of wider context of the research that already exists. Hopefully a lot of the time it might agree with the research out there and you can bring that in, but if it doesn't agree, then that is really interesting as well, and you might want to look at why. You might have used a new method, for example, that no one else has used. Why is this significant? But also bringing back in the importance of the science. So if we use the crop yield example again, why is that important? You might want to talk about global hunger, a growing population. Why is that science so important, and why should people read it? And again, conclusions kind of a mistake is conclusions just repeat the results instead of interpreting them. So I always say in your results section, it's almost a case of say what you see. You describe your graphs, you describe any visuals, and you state the statistics. Whereas in the discussion, you talk about why are we seeing these results? Why are they important? Is there any research papers or any other kind of research that's seen these before or not? And why overall is this important? So explain why your results matter, and also tie these findings back to your original question. Sometimes in the discussion, you might want to split that into subheadings. The answer, for example, I suggest at the beginning, you have your overarching question and split this into smaller aims. So you might want to kind of tie those aims into the discussion and talk about where you answer each of those. And then you conclude by answering the overall question. So how has the results for each of those sub-questions helped you answer that? And then finally, as I said a bit earlier, you might want to suggest limitations, next steps, applications. Why is it important? If you maybe had more time or more resources, how would you change it? Even if you have results that you feel are not kind of as good as you'd liked, it's always good to kind of evaluate that scientific process. And even if you can come up with an idea to evaluate why next time you might be able to make an experiment work, for example, is still incredibly important. So I think this is just concluding, but the best practices for strong research. Hopefully I've kind of discussed these in great detail. But first of all, start with a strong question. Make sure it's really focused and think about what aims and objectives you might use to help you answer that specific question. Make sure you build an alignment between the question, the design, and the data. So make sure the data you're collecting is really helping you answer that question. And think about the statistics or the other data kind of analytic methods you're going to use, and how does those help you answer that question. Make sure you keep your process transparent, and the best way to do that is to kind of write in your methodology section. I always suggest you write it in a way that someone else could read the recipe, so to speak, and follow it exactly the same. That is the best methodology. It doesn't need to be complex. They need to be able to repeat it exactly as you did. Make sure you can communicate really clearly and confidently. So think about clarity and conciseness in your writing. Don't necessarily worry about using complex language, but if there are some words that are inevitably complex, think about defining them, making sure that people can understand throughout. And finally, revise with feedback, get advice from others, but also use that in your conclusion section to kind of talk about how you'd improve your experiment next time and what you've learned. So this is just kind of reiterating that some of these have been said throughout, but in terms of tips and tools. So for sources, these are just a few, but Google Scholar, JSTOR. I find Google Scholar to be the best because it takes you to lots of different journals that you can read, and you can find different research papers in pretty much every field. You can manage your citations using Zotero or Mendeley. I highly recommend this. I used to do my citations by hand and it takes ages. So taking that time to get to grips with a reference manager is so important, and in the long run will save you so much time. And it's far easier to change the formatting of references once you've got it in a citation manager. Thirdly, for analysis, again, Excel, SPSS, Python. If you're confident with the command line, you can use various things on Linux, such as like Bash or Perl, to help you analyze as well. And there are various other things like MATLAB that you can also use, depending on the context of research and what subject you're doing. And finally, for writing, there are various kind of online sources to help with kind of clarity of language. So Grammarly, Hemingway, and ChatGPT. However, I'm sure it's important to kind of emphasize that everything should be your own work. And these are more important really for kind of structuring or clarity of language rather than like the work itself. So I think that's everything. Yeah, there we go. Okay, so that's everything on the last slide. So now if anyone has any questions, I will hand back to the admins, and thank you very much for listening.
Perfect. All right. So anyone can put in the questions in the chat box and we'd be happy to answer them. Quite a shy audience today, actually. All right. I don't see a lot of questions. Perhaps, Asia, I have some questions. You can answer them, so it may be informative for the audience itself, right? So, how long does an actual, like, I mean, research, what do you say, project take place actually? Because, like, we have worked with some of the other institutions where it's usually like in the course of the summer, right? Like, how does it work exactly?
So is that through Rise? I would say for Rise, it's probably better for one of the Rise admins to kind of answer that.
Okay. Okay.
Um,
Sure.
I'll take that. Thank you for your question. So typically, students that work with us for research, the program is for 2 months. In those 2 months, that's about 2 hours of direct sessions with our team each week, and about 2 to 3 hours of homework from their end. So you could say in all, it's a 40-hour time commitment across 2 months. Obviously, in those 40 hours, we're not doing research comparable to a thesis for a PhD candidate, but at the same time, it's a good short form format for research when they get some insight and understanding about the process. And we're also able to help them submit their work for high school level journals, conferences, and awards. where they can get some recognition for their work as well.
Perfect. All right. So there are some questions in regards to the publication's cost itself. Like, do they cost a bit?
So normally we go for journals that have either no publication cost or low publication cost. So I would say on average, most of the journals accessible for high school students, the publication cost would range from $0 to $150. This is the fees involved for reviewing the paper. The award would have some sort of requirements where students need to complete, or there would be some sort of logistical reviewing required from the committee as well. So these typically cover those costs at the admin's end as well.
I see, I see. And usually, like, is there a little bit of like due diligence in terms of like the journals itself? Because there are some predatory journals out there, right?
Right, definitely. So I think there's a list of priority journals that high school students must be aware about and to
Mhm.
ignore them at all costs. This is extremely important as once you sort of name drop those journals on your applications or your activity list, the admissions committee is very mindful that these are pay-to-play journals, which basically means that to get a publication, you can just pay a specific amount and then they publish your work in that particular issue of the journal. So
Okay.
the journals that we focus on are peer reviewed. They have high impact scores and they have a long standing sort of reputation in the academic community. So we want to focus on those kind of journals where acceptance rates are sub 20-25%. Again, slightly competitive for high school students, but at the same time, that's what makes it more prestigious when they get accepted to these journals as well.
Okay, perfect. There's some more questions. Do we keep it after your session?
Yeah, I'll just give a quick overview of what RISE does, and then we can jump right back into questions as well.
Okay.
So, hi everyone, my name is Shreyans. I'm the co-founder here at RISE Global Education. Just a quick summary of what we have done at RISE over the past couple of years. So far we have a team of about 250 PhD mentors across various disciplines in STEM, humanities, arts, and social sciences. Big thank you to the Go to Prep University team and Asia for hosting this session for you guys today. A bit more about where our students come from and what have we achieved so far. So over the 2 years, we have supported over 1,000 students from 40 different countries. We've had 150 plus acceptances to awards, publications, and conferences where our students have gained recognition at the international level. That's something we're very extremely proud of in our student cohort. But more importantly, even beyond the numbers, what is extremely something that we focus on in terms of the ethos of RISE is that personally seeing students ask critical questions, think about topics that they would not otherwise look into is something which research motivates them to see problems as opportunities and to create new ideas into actionable insights. So that's personally what I believe is the standout factor for high school students pursuing research. Publications, awards, conferences, all of these look good on the resume, but something that you take back with you is what you truly are passionate about. And that's where RISE comes in, where we help you find what specific domain are you truly passionate about. And then you can go into university confidently pursuing that over the next 3 to 4 years as well. So I think that's where RISE comes in as well. I'll also highlight a couple of factors about research, why it's uniquely important, and why I personally believe that research is for everyone and should be taken up at a high school level as well. So I think firstly, just to understand a bit of context about research in the most simplest sense, it's about taking an idea as a problem and then looking for different approaches to find a solution to that particular problem. It does not mean to solve the problem entirely, but it means that you make some headway into finding one interesting way to approach the problem and then share your idea, share your approach with everyone to comment and to understand your insights from that particular approach. So that's the way I like to view research. It gives me a good sort of expertise on the topic that I'm researching about. But for a lot of high school students, I would say their reading or their information is limited to the academic curriculum that they are bounded by school. So research gives you some more flexibility to look at topics that would otherwise be skipped in school and build a strong understanding, a strong set of expertise to talk about that as a more confident speaker in public forums as well. Number two is something which is something more tangible, which students and admissions committees often look for, is a sign of intellectual curiosity and academic rigor, which is highlighted by pursuing a tough activity like research early on in high school. So this definitely gives you an edge over your competitors or your peers when you apply to these top universities internationally. So it definitely helps you stand out when you apply to all of these competitive schools. And I think lastly, on the broader perspective, it's about making an impact on the world. So it could be the smallest way where you look at a problem in your community, you collect data around that, and then you start small campaigns where you help people with the insights that you gain from the particular problem. We'll talk more about this in the upcoming slide based on some of the student projects that were done at RISE so far. So moving forward, just a couple of ideas that students have pursued at RISE before, and something which is to take inspiration for all of you high schoolers on this call today as well. So one very interesting project which I would like to highlight is the project on pink taxes in India and its socio-economic implications. We had a student from a tier two city in India who was particularly passionate about female empowerment, and in this particular domain, she realized that female hygiene products in her particular territory or her state were priced at higher taxation rates than similar products available for males and other sort of other products in that particular domain. So, what this motivated her was to understand why this discrepancy was there in female hygiene products like sanitary pads and so on. And then she started her own campaigns about helping women in her particular area. And this then won her the Diana Award for social impact as well. So, this is just one example of how a student picked on an idea, wrote a research paper around it, and then took sort of actions to put that into effect and see an impact on a larger scale as well. Another interesting idea that one of our students worked on was AI-based optimization of battery management systems for enhancing electric aircraft efficiency. So this student was particularly interested in understanding how AI could be used to optimize the energy transitions or the energy conversions in electric aircrafts. So this was more of a futuristic project which was done using virtual simulations and data available on the open source. So this student was trying to understand if there were ways to run various simulations to understand how energy could be used more productively in the aviation industry. So this just goes to show the breadth of ideas where students can then look at or think about all the way from the aviation industry to socio-political issues as well. So research is for, I would say, anyone and everyone, and it gives you a good platform to think about ideas critically, and also with the right guidance, with the right support, you're able to produce research of high quality, which is something that stands out in your applications when you apply abroad as well. So that's a bit about RISE, and I hope that was helpful to get some insight about why we do what we do. We can go back to questions now and open to more questions that students might have.
Perfect. So there was one particular question: how can we select free publications in Q1 or Q2 for research article or case reports?
So in fact, after the webinar, the RISE team has actually created a guide which has all the publications for different disciplines, a list of over 20 plus awards, publications and conferences that we'll share with everyone who joined in today as well.
Okay. Is there a program in Rise that students could join? So I think they're basically asking, like, do you have different tiers of like research? What do you say?
Right.
Program? Yeah.
So we have two programs for research, a standard program and a publication program. The standard program is for students looking to write research papers without them needing support for the publication or the award competition segment. And then the publication program is a bit more hands-on with increased attention with the mentors, more frequent mentor sessions, and a bit more focus on the rigor and quality required for publications as well.
I see. Okay. I mean, those are the three questions. I myself will have some questions like so that students can actually get something out of it. So, say when you onboard a student, is there like an interview process you go through? Is there like something that you check? Is a student like eligible for a research? Like, how does that work exactly?
Right. So we're a selective research organization.
Mhm.
By that, I mean that each student goes through a two-step application process. There's a short application form that students are required to fill out. This would require them to fill out their academic scores, grades, relevant courses, past research experiences, and the unique motivation to pursue research with RISE. Once they complete the application form and the team reviews it, there's a one-to-one interview that we schedule with the students to understand their motivations better, to understand their preparation for research, and then to also level their research expectations with our program outputs. So after the interview, we select about 35% of applicants. That's been the acceptance rate that we have for our research batches so far.
Okay, okay, okay. Um, right. In terms of like the actual mode of communication, like how do they actually meet up with the mentors? Like, is it like purely email communication? Do they actually meet up online? And like even because of the time zones, also, how's that actually managed?
Right. So, what's very interesting is that we have a central point of contact called a program manager, which is assigned to each of our students that coordinates timing, schedules, rescheduling with the mentor and the student. In terms of communication, we use email as a formal mode of communication. Meetings are taken on Google Meet and Zoom as the two preferred platforms. And in terms of informal communications, sort of scheduling and other last minute changes, we use WhatsApp for any informal communication as well.
Okay, okay. And are there like any sort of like disciplines that are a little bit like difficult to actually do research upon? Like, that have, is there something that you've come across where you say like, okay, this is something that we cannot really help a student in?
So far, we haven't come across a discipline actually where we've been unable to help a student. What I find extremely interesting is very niche disciplines. So something like an astrophysics, aerospace engineering, neuroplasticity, and something which is very niche that students want to explore. We are able to support those kind of disciplines as well. So the entire range of disciplines from STEM, humanities, arts, social sciences, law, linguistics, you can name the discipline, and I'm pretty confident that our team can provide the perfect mentor for a student.
Okay, so a choice of mentor, is there like some sort of agency from the students end as well, or is it mostly from your end that actually allocates to mentors?
Right. So I think the initial mapping is done by our team, which understands the students' requirements and also understands which mentor would be the perfect fit. In case there are any issues in terms of teaching learning mismatch or any sort of communication barriers, we're okay to switch the mentor proactively as well. So I would
Hmm.
say maybe 1 in 20 cases at times students are not comfortable with the teaching style of a particular mentor, in which cases we swap the mentor proactively as well. But so far, we've observed that our team has been fairly good at mapping mentors with students based on the different data points that we have collected.
Perfect, perfect. Someone is asking about the cost itself, the actual cost of the entirety of the journey, right? The two main programs that you
Right.
have.
The publication program, which is the one preferred by most students at price, that's priced at 1,000 US dollars, and the
Hmm.
standard research program is priced at 1,600 US dollars.
Perfect. All right. Any other questions, attendees? You can always put in a chat box. We'll wait for a couple of seconds. If nothing comes up, we can wrap it up. Yeah.
Sounds good. Sounds good.
Okay. I'm having one other question that came in. Uh, no, it's the same thing. All right. Perfect. All right. So what I'll do is I'll just pull up contact this thing, contact details, so you can get in touch with our team. One second. Can you see the screen?
Yes.
Oh, okay, perfect. All right. So All right, so this was an excellent presentation. So if you'd like to get in touch with us, we both have a UAE number as well as an India-based number. So any GCC clients, you can definitely contact Ms. Mahin Shah, the center manager here. If you're out of South Asia, you can contact Mr. Varun Iyer. Marun Iyer, he's a country manager, right? So please take your screenshots, right? We are happy to help you out, no matter which university you're trying to get inside, right? No matter which journey you'd like to proceed with, right? Our team as well as Rise's team could actually help you out quite a bit. All right. Thanks a lot, Shreyans. Right. Thank you for joining us and supporting us for this presentation. And obviously, thank you, attendees. Take care. See you.
Yeah,
Goodbye.
thank you so much. Thank you, Asia.
Thank you.